Alright, now in this video, we are ready to begin working on our saving and loading code. Throughout the next few videos, we will be putting together a series of methods that will allow us to save out and reload our node network. We're going to need to address topics such as simple file I/O, of course, because we need to save the information that the nodes represent. We'll also need to deal with the fact that we need to serialize the node connections, where those connections are represented by references. So we'll need to look at an interesting way of handling these references so that they can be relinked after the nodes are reconstructed. So to get started here in this video, we're going to begin with the class that is going to house the NodeIO methods. So what we'll do is we'll go over to our editor folder and we will add a new class. We're going to call this class NodeIO. And we'll give it a second to bring up our new class. Once again, the very first thing we'll do is we will clean up our subnamespace, where we will remove the editor subnamespace. And there are a few using directives that we need to put in place. The first is going to be for Microsoft.xna.framework. And the second is going to be for system.io. Alright, now we can look at the NodeIO class. The first thing about this class is the fact that it's going to be static, because we want to refer to all of the methods inside of it as static as well. Now, as we put this class together, we are going to build the saving and loading functionality in stages. The first stage is going to be to set up our saving code. The second stage is going to be to set up our loading code. And the final stage is going to be integrating a Windows save and load dialog to make it easier for the user to manage their files. So, to get everything started, the first method we will be addressing is the method that will let us actually save out our nodes. So let's begin with the method definition. We're going to make a public static method with a void return type, and we are going to call this method save nodes. Now we are going to have this method take in a single parameter so that we can say what file we would like to save this information to. So we are going to create a string parameter called file name, and then we can drop in the braces for our method body. Alright, inside of save nodes there are a few interesting things that need to happen. Of course, the first of these is to establish some simple file I/O. We need a handle to some object that is going to let us create and write information to a file. In our case, the basic stream writer will work nicely. Now before we go further, I want to just say a quick note on the kind of file we will be writing. We're going to assemble a custom ASCII file format in order to save our node information. The idea is that the node information we need to save is really very simple. For a node itself, the only key piece of information that a node by itself is representing is a position. Everything else can be inferred just from the fact that it is a node. Now in addition to this position, of course, we do have to store the linked connections. But those can be stored simply as well. So what we're going to do is we'll make a file format that consists of simple lines. We will make what we are going to call N lines to describe nodes, and we will make C lines to describe connections. So an N line will be followed by node position, and a C line will be followed by some connection information. Now, to put together the code necessary to write this custom text file, once again, we're going to be using a stream writer, and because that stream writer holds a link or a handle to an actual file within our system, we need to make sure that that reference gets cleaned up. To do this in a more concise manner, we're going to put together a using statement. So we'll drop in the syntax beginning with using, then to get our using statement kicked off, we will create the definition of the object that we want to watch inside of the using statement. So here we are going to make a stream writer, and we will simply call this writer, and we will turn around and initialize our new stream writer. So writer equals new stream writer. We need to pass in a file name if we look at the second overload to the stream writer constructor. So we will simply pass along the file name parameter. Then we can close up our parentheses for the constructor and close up our parentheses for the using statement. Now I'm going to drop in braces around this using statement, and just a quick description of what the using statement is going to do for us is obviously it differs from the using directive, where the directive is simply responsible for bringing in namespaces or creating aliases. The using statement, on the other hand, is going to allow us to perform the same type of checks we would normally use inside of a try finally block, but it's going to do so in a much cleaner and easier to read manner. What's going to happen is, with this using block focusing on the writer object, it's going to ensure that the dispose method of this object gets called regardless of how we exit the using statement. Meaning, if we exit normally by simply hitting the ending brace, it will make sure that dispose gets called and the file handle gets cleaned up. If we encounter an exception inside of the using statement and exit in a way that doesn't finish off all the code inside, it will still ensure that dispose does indeed get called. So this prevents any form of resource leak or any form of open handle that we no longer have access to. Alright, so now here inside of our writer, let's begin working on the code that we'll need in order to save out our nodes. I'm going to begin with the node saving code by itself, since writing out the nodes is relatively simple, and I just want to show what our format is looking like before we add all of the connectional information. So I'm going to begin with an IEnumerable variable to represent our node list. So starting with IEnumerable, we'll make this enumerable of type node, and grabbing just a bit of spelling on node, we will call this variable nodes. And nodes will be equal to actor.actors.ofType, and we will specify node as the type we would like to filter, open closing parenthesis to invoke the method, and then terminator, and that will take care of gathering our nodes list. Now we need to loop through each of these nodes individually so that we can write out the information the node represents. So we'll put together a for each loop, and we will say for each node in nodes. Now looking at these nodes, we're going to begin with just the code, or rather just the positional information that the node contains. And again, as I was describing earlier, we're going to call these n lines simply because we're going to prepend the line with the character n. So we will now address the writer, streamWriter object. We will tell it to write a line to our file, and the write line takes in formatting, or rather allows formatting, in a manner similar to console.writeLine. So that means we can begin with a format string and then specify a series of arguments. So let's first put together the format string itself. Inside of the string, we're going to set up a series of comma-separated fields. The first of these fields is simply going to be the character n to indicate a node line. Then we'll drop in a comma, and we will place an argument for argument 0, and a second argument for argument 1. Alright, for the arguments themselves, we're simply going to store the numeric position of this node. The node, of course, uses a vector 2 for position, but that vector 2 in turn represents 2 floating point numbers, and we can easily write those numbers in a textual representation inside of this text file. So we're going to simply extract the x and y positions. So we will take our node, and we will address position.x for argument 0, and node.position.y for argument 1. We can then put in our closing parentheses for the writeLine statement and drop in a terminator. Alright, with all this code in place, we have the beginning of our save nodes method in place. We can see that we can build and everything should get saved out. Now let's put together a scenario so that we can test this code and make sure that it's functioning properly. We're now going to jump over to our scene editor. Then we're going to scroll up and locate the very end of our keyboard input checks. At the very end of these, we're going to create a new else if statement, and we're going to check for the case when the user hits the Control-S key combination. So the way we'll do that is we'll check and see if the incoming key is equal to keys.s and the control button is pressed. So we will ask keyboard input if the control key is down. So we'll run, or rather check, is control down. Then inside of this check, if we come up and found that the user has hit Control-S, we will invoke our save nodes method over in NodeIO. So we'll grab the NodeIO class and invoke save nodes. Now we need to specify a file name, and we don't yet have our dialog code in place. So we don't have a dialog that the user will see to choose a file name. So for the time being, we're just going to type in a temporary file name. So what we'll do here is we will say save nodes and then simply drop this in as nodes.txt. I'm not going to specify any path information, and that way as we are running the app here inside of Visual Studio, we should simply get this file created alongside the executable itself. So with this in place, it's now time to test things out. So let's run the game. And we can see that we have a lot of nodes in place because we still have our full grid building. And this will work fine for an initial test. So let's go ahead and hit Control-S. And we see that we have no indicators that anything went wrong. So let's close out the game, and let's bring up the folder that our game is currently stored in. Next to our game's executable, we can see that we did get a nodes text file created. And if we open up this text file, we can see that it has lots and lots of lines. So just bringing this file on screen here, we can see that we have lines beginning with the character N, we have fields separated by commas, and we have series of numbers which are representing node positions. Now, in order to make a more simplistic scene, to make it easier to see exactly what nodes are getting saved, I'm actually going to comment out the code that is currently generating our grid. So back up in the constructor for Scene Editor, we are going to comment out our initial grid and then the center deleting code. So with all of this in place now, let's run the game once again, hold Shift to create some nodes, and just create a simple A-frame looking series of 3 nodes, and hit Control-S with these nodes in place. Now we can once again close out the game, bring up our files here, and load up nodes. We can see that we have only 3 end lines with various positions assigned. So we do see that we are now able to save positional information. This now brings us to the next half of what we need to do in order to save out our nodes. Now, of course, the nodes, the key piece of information that nodes are holding, in addition to a position, is a series of connections. That's what's actually making our path node network. So it's, of course, very important to save these connections back out. Now, saving the connections brings up an interesting topic. The connections themselves are actual node references. So we need some way of saving these references, or rather serializing them so that the references can later be reconstructed. Because in actuality, we can't take the reference itself and save the information it represents, because a reference is simply a link to a position somewhere on the heap. And that position is going to change depending on how the nodes themselves are created, not to mention how memory management is going to work inside of .NET itself. So what we need to do is we need to come up with a way of resolving a piece of information that indicates our connections without using real actual references. The way that we will approach this is we will assign each of our nodes a numeric ID prior to saving. Then we will save the connections by representing the connections between IDs rather than references. So you can almost visualize this as replacing the references with numbers and then saving the relationships between these numbers. Then we'll simply reverse the process when we need to load our information back in. Now, at the moment, our nodes don't actually have a numeric ID. And because of the way our code is working, our code never needs a number to be part of the node itself. So we would rather keep that part of the node class very clean. So instead of messing with node itself, we are going to build a dictionary of IDs that are associated with nodes. That way we can create the node IDs on the fly as we save, rather than keeping them continuously as part of our node class. So here, back inside of our save nodes method, inside of our using statement, we are going to create the dictionary that will let us map ID numbers to specific nodes. We're going to make a dictionary. For our key type, we are going to have a type of node, and for our value type, we are going to have a type of int. We are going to call this dictionary node ID map, and then we will turn around and instantiate the dictionary by saying new dictionary with the appropriate types, and that will take care of the dictionary itself. Now what we need to do is we'll need to actually set up our code and run the node loop in 2 separate passes. We need to do this to make sure that all of the nodes get assigned an ID prior to looking at their connections. So what that means is when we're inside of our first loop, which is saving out the nodes themselves, we will also build the dictionary. Because in this case, we already have the first loop in place since we need to save the node information itself. So right before we write out our node information, we're going to create a node ID number. We'll create this first as a local variable since we need to use it in 2 different places. We'll make a variable called int node ID, and we'll set that to simply be the number of nodes that we have currently looked at. And to know how many nodes we've looked at, we can just look at this map that we're about to build and see how many nodes it currently contains. So we can simply say node ID map dot count to say how many nodes we have addressed so far. Now if we used count by itself, we would end up with a 0-based ID list because of course the first time we look at this we have no nodes mapped and therefore we would have a node ID of 0. Just for the sake of readability in the file, I'm going to set this up so that our very first ID number is actually 1. And we can do this by simply offsetting from our count by adding 1. So that way the first ID will be 1, then count itself will be 1, meaning the next ID will be 2, and so on. Alright, now that we have assembled a node ID for the specific node in question, we're going to make sure that we store that ID number into the node ID map. So we'll take our node ID map, and we will assign the element for the current node. And we will set that element to be equal to node ID. So this is really where we have created the relationship between an actual node reference and that node's ID number. An added advantage here is since we are using a dictionary, we will have very fast hash table based lookups based on the node reference itself. So this will make the code significantly faster once we get into the connection resolving portion. Since at this point, if we are given any node reference, we can very quickly resolve a node ID number. Now that we've got this number created and stored in the reference dictionary, or rather in the ID dictionary, we do need to make sure that this ID number also gets saved out into our node's data file. Because of course, when we reconstruct all of our nodes, we need to make sure we reassign the exact same ID number in order for the connections to be reestablished properly. So what we'll do is we will add one more field to the lines in our file. I'll add an additional comma and then specify a final, you can say a third argument as argument sub 2. Now I would rather have the node actually appear as the first argument, so when we go to list these arguments, I'm going to drop in node ID as the first argument before positions X and Y. Alright, so this will take care of building the ID map and saving it out to file when we're writing out our individual nodes. Now we need to address a secondary loop that is going to go back through all of our nodes and then create a subloop that is going to loop through all of the connected nodes. So basically we'll pull out each node one by one and inspect all of that node's connections. Then we'll save each connection as an individual line inside of our data file. So we'll assemble the loop as a for each loop. Once again we will say for each node in nodes. And in just a second I'll correct the spelling on that. And for the variable name, we really would like the name node. Now inside of our loop, once again, the relationships between nodes are also between a node and all of its connections. So we will create a second for each loop. In this loop, we will say for each neighbor in node.connected. So once again, this is where we pull out and inspect each node individually, and then create a subloop to inspect all of the neighboring nodes that are connected to the node itself. Now, inside of this loop, since we have the main node, we have all of the neighbors that are connected, we could say that the link of node to neighbor is what we are going to term a connection. And we need to be able to save that connection to our file. Now once again, we can't save the node and neighbor references, but we have just run a loop that has built a dictionary of IDs based on nodes. That means we can reference this node ID map for each node and for each neighbor. Now that we can establish this information, we're actually ready to write the information to our file. So we can address the writer and invoke the writeLine method. Once again, we need to assemble a format string, and we are going to call the connection lines simply C lines. So our first field is going to be the character C. We'll drop in a comma, and then we'll specify argument 0 for our formatting, followed by a comma, followed by argument 1 in our formatting. We can then finish off the formatting string. Then we can move over to the arguments themselves. Now in this case, the connection lines are simply going to be a connection between two numbers. The idea is that we will say the connection is between the node ID in this column with the node ID in the second column. So what we'll do is we'll grab the node ID for our node, then the node ID for the current neighbor. And once again, in order to grab these IDs, we will use the dictionary to look them up. So we will say node ID map sub node, and that's connected to node ID map sub neighbor. And then with these two arguments in place, we can put in our closing parentheses, terminate the writeLine statement, and that should be all we need to do for the connection lines. So with this code in place now, let's go ahead and build and then run our game. Once again, let's create the same series of 3 nodes all connected, then hit Control S to get these saved out. We can then close the game, switch over to the file system, load up our nodes file, and see that we have some connection lines in addition to the nodes themselves. You can also see that the node information now contains node ID numbers. So we have nodes ID 1, 2, and 3. We can then see our connections here where 1 is connected to 2 and 2 is connected to 1, which makes sense because our connections are established in a bidirectional nature. We can also see that node 2 is connected to 3 and 3 is connected to 2. So for these 3 nodes, we actually have 3 separate connections that need to be established. So with all of this information in place, we now have our node graph being saved out to file. So here in the next video, we'll take a look at loading this information back in. And with that, that's going to wrap up this video.